All right, welcome back to Chapter 4, Section 3, Writing Functions. We're doing example 3 where we're going to write an algebraic function based upon a situation that's been given to you using words. So the steps for this, we're going to have to identify the independent and dependent variables, and we can use x and y like we normally do. Sometimes we might actually use letters that stand for the things. So we use A for area, or D for distance, or C for cost, T for time. Sometimes that actually makes it a little bit better and it helps other people understand what our function is. The x and y are just kind of like placeholders. It's kind of like, all right, if you don't really have a story, just use x and use y with it. That's because x is like the least used letter in the English alphabet. So if you look at the dictionary for like the letters that have an X in them, that's the smallest part. So it just kind of, and it's also easy to draw. All right. So we use X for things that we don't know. All right, which is usually the case for variables. But again, we also can use, and we should use, English letters. Excuse me, if we were learning this in a different situation where we were using different languages, we wouldn't use English. As a matter of fact, I'm getting ahead of myself. There's a lot of letters that we use that stand for things that actually come from French, believe it or not. A lot of people in Europe, to be Eurocentric, used French as the language of mathematics, okay? And then for mathematicians across the world, because there's been many mathematicians in places other than Europe, have used their own languages and stuff. As a matter of fact, just the numbers that you're using are Arabic based upon Hindu numbers, excuse me. But I'm getting a little ahead of myself. I just caught myself when I said English. We're using English because I'm speaking English. That's all. But whatever the words are that we're going to use, we can use that to represent the variable. All right. I gotta check my privileges. That's what I'm saying. So let's do the first example. A lawyer's fee is $200 per hour for her services. So what are the two things that are being measured in this situation? Unlike the last video, excuse me, I need to get some water. Unlike the last video, I'm just going to straight up go for it. The two things that are being measured here is the time that the lawyer is going to work. And if you know anything about lawyers, they will bill you by the hour, by how long they're going to work for you. Okay? And of course, this is measured in hours, but the actual variable is time. So don't say hours. All right? And the other thing that we're measuring in here is how much it costs to hire that lawyer. And in that case, we're looking for the total cost. All right, I'm going to put total here, because I know it costs $200 per hour. One thing, I want to point this out, all right? Constants are not variables. And this is something that I have to discuss every year. Constants are not variables. Well, duh, a variable is a measurement that changes. Constants are things that don't change. However, sometimes I think that students just look at a problem like this and they go, wait, there's a number. Numbers mean math. It's got to be the number, okay? So I'll say, well, what's the independent variable? And they'll say 200. Well, 200 is a constant, so it cannot be a variable. 200 is, it's a number, all right? The 200 per hour is a rate, and we will talk about rates in the next chapter, chapter 5. So we're going to kind of hold that off for a moment, okay? All right? What are the two variables? Well, one variable that I can measure is how much time this lawyer is working on this case, or whatever the lawyer's been hired for. And the result of that is the cost. Now, usually, and I cannot think of a different example, but usually if time or cost either one. This one has both of them, but if one of these is in a problem, time is almost always independent and cost is almost always dependent, or at least total cost. All right, and I should have wrote total cost. So this is the independent variable, and this is the dependent variable, and I'm going to abbreviate because I need more space here. All right, so what letters are we going to use? All right, I could use X or Y. Let me do that, just because that's what we're used to. So after working 1 hour, the lawyer is going to charge, it's going to cost the client 200 times 1. After working 2 hours, it's 200 times 2, $400. After working 3 hours, it's going to be 200 times 3, which would be $600. So what's my relationship? Combining what we did in the first video with the second video, it seems like my relationship is I'm going to take 200 and I'm going to multiply that by the number of hours that the lawyer works. And then when the lawyer sends out the bill, that's going to be the total cost. So y equals 200x. The only other thing that you could have done with this one is I could have also used t for time, and I could have used c for cost. Now, let's say that we're working in groups and one person writes y equals 200x and another person writes c equals 200t. And then you start like, well, wait a second, why did you get something different than what I got? There's an easy way to fix it. It's called defining your variables. So for this one, you could have written t is the time that the lawyer works. I'm going to run out of space here. Maybe you can see it. And C is going to be the total cost, or how much the lawyer is going to charge. All right. So if you use X and Y, even if you use X and Y, excuse me, let me start over. Even if you use X and Y, or if you use other letters that kind of make a little bit more sense, oh, T's for time, C's for cost, I get it. You should define your variables because that helps other people understand what it is that you are talking about. Okay, so let's do the next problem. The admission fee to a local carnival is $8 and each ride costs $1.50. Let me scoot that up a little bit. All right, so what are the two variables, two things that are measured in this situation? All right, so we're talking about money. So again, we've got total cost. What's the total cost of your trip to the local carnival? And then what's the other thing that's being counted? Well, you pay once to get in $8. That gets you into the gate. So that's not going to change. That's constant. Each ride costs $1.50. $1.50 is also constant. And again, constants are not variables. But what is in here that changes that, and by the way, we'll talk about this, you actually get to decide how it changes. It's how many times you're going to ride a ride. Now, this isn't like Valley Fair or someplace like that where once you pay, you can ride as many times as you want. All right. This would be something where there's a fee to get in, and then you got to buy tickets. So you buy tickets, and each ride is going to cost $1.50. Some places are like that. Some places are not. Right. So don't worry about that. But you get to decide how many rides you're going to have. So, you buy a ticket, say, all right, we bought this many tickets and we're going to, go on this many rides. So I'm going to say the number of rides. Now, this is the independent variable because you get to choose how many rides that you're going to go on. The total cost is the dependent variable because how much you pay depends on how many times you ride. And I said, let's define our variables. I kind of already have. I just have to pick a letter for it. I can use X and Y again, or I can use N for the number of rides, and C one more time for the total cost. All right, so that's the first step. Now the next part, I actually have to write the function. So imagine the situation. How many times do you pay $8? We only pay that once. So I'm only going to have $8 show up once in my problem. Each ride costs $1.50. So I could do, like, if I do 7 rides, that'd be $1.50 plus $1.50 plus $1.50 plus $1.50 plus $1.50 plus $1.50 plus $1.50. I think one more time. Okay, plus $1.50. I think I counted as 7. All right. Repeated addition is multiplication. So I'm going to multiply the 150 times the number of rides that I have. So I'm going to write $1.50, and I'll put the 0 in there just to identify that we're talking about money. I'm going to multiply that times the number of rides. So if there was no fee to get in, that's all that you would pay, and that's what your total cost would be, right? So if you ride 1 ride, it's $1.50 times 1. If you ride 8 rides, it's $1.50 times 8. However, there's an additional fee of the $8 that you have to pay, so I'm going to add that $8, and I'll put 2 decimal places even though it's not there, just so you know there's money. And that's going to tell me what my total cost is. Two more. I'll pick up the speed a little bit because I think this video is getting a little long. Stephen buys lettuce that costs $1.69 per pound. That's a pretty good deal, right? So imagine Stephen, he goes to the store, the grocery store, farmer's market, wherever he goes, and he really needs lettuce. Maybe Stephen, you know, like most people just buy a little bit of lettuce so they can make sandwiches for lunch. But maybe Stephen owns like a small restaurant, okay? So he needs to buy bulk lettuce. Making the problem too hard. I'm going to stop that. He gets a special deal where it's like $1.69 per pound. What are the 2 things that are being measured here? Well, first of all, you have to measure how much lettuce that Stephen's going to buy. And since it's per pound, then it's the weight of the lettuce. It's measured by weight. And I don't know if you've ever gone to, like, you know, the grocery store. If you buy produce, you'll see the clerk in the checkout. Sometimes you buy produce and they'll put it on a scale real quick, and then the register will tell how much how much it weighs, and therefore how much it costs, which is the dependent variable, which again is the total cost of the lettuce. And I said in a previous video that total cost is usually the dependent variable. So first you have to figure out how much lettuce Stephen's going to buy. That's the independent variable. And how much it costs is going to depend on the total weight. Now, let's pick some letters that stand for the variables. You'd be tempted to pick L for lettuce. But here's the problem. Look at that L. If I just write it, like I'm going to write it over here, it looks like the number 1. So even though we want to use letters that stand for things, to be honest, we want to make sure that things are not ambiguous. We want to make sure things are clear. So we're going to avoid using L when we can. Sometimes in geometry, we actually use an L, like a cursive L. Can you see that? We use a cursive L when we talk about length. Okay, if you talk about areas, length times width, so you see that. So let's avoid that for right now. We could use W for weight, and we could use, again, C for cost. Or we could just use X and Y. You just have to define it. I'm going to use W and C for cost. All right, so what is the total cost? Well, if you buy 1 pound of lettuce, or Stephen, it's going to be $1.69. If you buy 2 pounds, it's going to be $1.69 plus another $1.69, which is 2 times $1.69. If you buy 3 pounds, it's $1.69 times 3. See what I'm doing there? So each pound of lettuce that you increase by, you're going to multiply by that. Repeated addition is multiplication. So my equation is going to be total cost is going to be $1.69 times the total weight of the lettuce. All right, last one. Going back to amusement parks. An amusement park, Valley Fair does this, but it's not $6, let me tell you. All right, an amusement park charges a $6 parking fee. They're gonna get you one way or another, plus $29.99 per person. So if you are one person, you're going to pay $6 to park plus $29.99 for your ticket. If you take a family, it's going to be $6 to park your minivan plus $29.99 plus $29.99 plus $29.99 plus $29.99 for each person that you're going to have. So what are the two measurements that we have here? We've got the number of people that are going to the amusement park. And one more time, it looks like we've got total cost. You'll notice that a lot of these have total cost, and a lot of them also have time. This one doesn't, and the previous one didn't, but a lot of them will. All right? This is my independent variable. This is my dependent variable, because the total cost depends on how many people are going to go. What letters are you going to use? One more time, I can use X and Y, no problem with that, but I'm going to use N for number of people, that hashtag. I know you guys are thinking Twitter, but that actually in math, that means number, okay? So that's a shortcut for number when I'm counting something. I'm going to use N for number of people. You could use P for people. That's fine. Just tell us what you're going to use. And then one more time, I'm going to use C for total cost. All right. Each person is going to be $29.99. If I take 7 people, I'm going to add $29.99 7 times. So that's going to be 7 times $29.99. Since I don't really know how many people I have N. That's going to be, I'm going to write it down here, $29.99 times N. You also pay a one-time only parking fee of $6. And that is going to give you your total cost. Okay, I will see you in the next video.